So if I recall correctly, none of you have taken an economics class. Economics is, wait for this announcement here. Carly, economics. The science of goods and services being purchased and sold. What's the question?
What page is it?
I don't know, 561, it's 9.3. Right. So in 9.3, we're going to take a look at supply and demand. So, you haven't studied it, but you can probably guess that businesses supply goods and services, and purchasers demand them to some degree, right? What do you think would be one of the biggest determinants of how much of a product that you demand? How much the price? There you go, price. So price is the main determinant of how much of an item you would demand, and it's also the main determinant of how much somebody would be willing to supply, right? So if the price of an item, we'll use the example, it's like the classic economics example, widgets, right? Whatever, it's just a generic term for whatever, some product that's made, right? If the price of widgets is high, you think you would demand more or less of them? Less, right? And what if the price of widgets is high when they're sold? Do you think that the business would be more willing to produce more or less? Well, if the price that you pay is high, they would be willing to produce more of them. So there's a little bit of a conflict here, right? We can graph this. But there's this equilibrium price, right, in which they're going to supply a certain amount that's equal to what you would demand, okay? Now, when we're going to talk about price determinant of demand, there's other things that come into play, right? These are non-determinant or non-price determinants of supply and demand. So let me give you a quick graph here of the demand function, okay? Demand function. So it'll look a little like this. That axis there, and that axis there, okay? And on this axis down here would be the price of some item, good or service, a widget, right? And up here would be the quantity demanded, so QD, right? So at a low price, we just agreed that, right, well, that's a slight error because the technical way to think of it is the quantity demanded, right? We'll just use, or sometimes what they do is they'll just put D for demand. It's not exactly accurate. It's like the next marginal unit that's demanded, right? So you said, like, if the price is low, the demand would tend to be what? If it's not right, high. And as the price increases, the demand for that product would be, right? So it's kind of, so it'd be something might look like this, right? It goes down. And sometimes we'll just use a straight line to keep things simple, right? But it's usually got a curve to it like that, okay? So that's the demand function. And so when price changes, we move along the curve here, right? Okay? The curve can shift too. But as with any science, right? You take science classes, right? You got experiments, right? You only want to like investigate one variable at a time to see how that changes it, right? And you want to try to eliminate all the other variables to make sure you know what that variable does specifically, right? So movement along the curve okay, is dependent on price only. It is dependent on price only. Okay, no other factors will move this along the curve. And what we say is, if we're only talking about price, like we're not considering any other factors. So what we say is all else being equal. All else being equal. Right? And there's a term for all else being equal in economics, if you ever study it. It's a Latin term, right? It's known as ceteris paribus. Ceteris paribus is Latin for all else being equal. You can probably see that in the name, right? You ever use the term et cetera? Meaning a whole bunch of other things. Ceteris, right? Paribus. You're familiar with the word parity, maybe? Like equal things on par with each other, right? Okay. So ceteris paribus, right? There's other determinants, though, right? Like what else could affect how much of something you demand? Okay, right? So like your expectations, right? What about your income, right? Maybe you lose your job, right? Or town, the factory goes out of business or something like that, right? A lot of people out of work. Do they demand less of this? Does that have anything to do with price? So we're not moving along the curve if things like that happen, right? So other determinants like that, other determinants, and this is very important, they actually shift the entire curve, okay? Other determinants shift the curve. All right. So some of those determinants that are other than price could be income changes, right? Right, across a population. You mentioned taste, like if something's kind of cool, you said, right? Tastes, like something could be like a fad or in fashion, you know, for a few months and then not so much, right? Probably think of some things that are like that, clothing, most likely, that kind of thing. What about if there are more buyers in the market?
Yeah.
And maybe a certain population generally is getting older, right? And they generally, if you're older, you make a little more money, right? So maybe like the number and age of buyers. All right. Anything else you can think of? What about when the government does things? Most of the time that's true. Like regulations and taxes, right?
Yeah.
So if there's some product out there that there's a certain demand for and the government suddenly imposes a tax on it or increases a tax, right? The quantity demanded would go down, but it's not moving along the curve, right? It's shifting the curve, right? So we could add like regulations, regs, and taxes. Yeah, most governments have an uncanny ability to really mess things up, right? Natural disasters, right? Like a hurricane in the Gulf might threaten the oil supply, right? Right? You don't have as much of that to go around. So I'll just say, et cetera. Number six, ceteris. Okay? So any of these things, anything other than price moves the curve itself, right? And price changes are moves along the curve. So that's the demand function, right? So there's also a supply function. Do you think it'll look the same? Yeah. Supply function. So make a little graph here. We'll call this price again, but up here, we're going to call it quantity supply, QS. All right? So if the price of an item is low, and you had a business making that item, would you be willing to make more or less of it if you're getting less money for every one that you make, right? But then if the price increases, you'd be, all else being equal, willing to make more of it, right? So the supply curve is like the opposite of the demand curve, right? Okay. So what happens if we were to graph both of these together? Would you agree they'd intersect somewhere?
Yes.
Okay. That would be the equilibrium point, right? And all markets tend to go to some equilibrium because that's like the happiest, most natural place for anything in equilibrium, right? Like if you have a hot cup of coffee sitting in a room, right? It's hotter than the air, but eventually coffee gives off heat and right to the room, and they end up at the same temperature. Equilibrium, right? It's natural tendency. It's science. It's physics, right? It's not like somebody's causing it to happen. It just happens naturally. Well, let's go ahead and put these things. Well, let's define equilibrium, I guess. So yep, do that. E, yeah, we'll do it again. Okay, E, right up here. What in the wide world of sports, Carly? Q, U, I, and let me see if I can move down now. L, I don't understand this. L, I, B, R, I, U, M. That's the price at which quantity demanded and quantity supplied are equal, okay? Price at which QD and QS are equal. Okay? So markets always naturally seek equilibrium. Okay? It's a natural phenomenon. Right? So markets always naturally seek equilibrium. It's not like a law somebody says we need to have this in equilibrium. It's just a matter of human nature that it happens, right? And if you ever read any of Adam Smith, he's a famous economist, wrote a book back in 1776, a big book. It's about 1,200 pages. I have the book in my house. I have not yet read the entire thing. But I did study in college, right? This natural force to seek equilibrium, I'll just put this in parentheses, Adam Smith. It's what he called the invisible hand.
Oh, yeah.
You've heard that term, have you?
Yeah.
Okay. Invisible hand. All right. He wrote about this and many, many other things back in 1776 in his book, The Wealth of Nations. It's a tough read. It's a long book, and it's written in an old English, prosy kind of, you probably read some stuff in English that was like that. We're going to try to get through the 1,200 pages. You read one sentence the way they would have phrased it back then, and you have to stop and think, well, what does that really mean, right? But anyway, it is a challenge. So let me put both graphs on the same coordinate plane here, and we'll look at equilibrium. So I'm going to do it in black. I'll use a couple different colors maybe. So if I do this, right, we're going to call this the price axis, right? And this will be, I'm going to just call this Q up here for now because it can be both supply and demand, right? And so I'm going to use a straight, because this will be easier just to use a straight line to visualize it, right? So here's our demand curve, right? Or, yeah, squeeze me. Supply curve, how about that? And then this would be the demand curve, okay? The price goes up, when I demand it goes down. So right here where they intersect, okay? this point right here, whatever price this is on this axis, that's the equilibrium price, okay? So I'm going to label some prices here. So I'm going to put some price right here. I'm going to call this, use blue for P1. So price 1, right? And then I'll call this next one here, keep track of my colors, price 2. And then maybe over here we'll call this price 3, right? Whatever numbers they are. I don't know. We're, you know, paying for the widget. Okay? Right. Interesting meeting, I assume? Okay. So, at this particular price, right, what's happening at price 1? If we go up here to the supply curve, right, and come over here, right, well, they'll be available for you. You can catch up. Just leave a good half a page blank when you start out now, right? So this would be, if that's price 1, this would be quantity supplied 1. We'll call this QS1, right? So that's where that price will hit that graph, okay? And then if we keep going up here, well, I should have made this a little column. Let's see here. I need to have that moved a little bit. Put my Q up here, right? So if we keep going up to the demand curve for this, right, and go over to the axis, this will be quantity demanded 1. All right? So that price 1, where it's lower than that equilibrium price, what's happening here? Oh, first let me ask you, like, if there's a whole lot of things out there, what do you think happens to the value of them? It goes down, right? If there's very few of something that you might need, it go like apples, right? Let's say something happened and there's only one apple tree left on the planet, right? It could probably, the price of that apple tree, the stuff that comes off, would probably be pretty high, right? Not many of them, and people want them, and, you know, it goes to the highest bidder. Okay? So, at this low price right here, here's the quantity, right, value they'd be willing to supply, and here's the quantity you demand. So there's very little supply, but a lot of demand. So what do you think will happen to the price 1? What force will happen here? It'll tend to force that price up, wouldn't it? Okay, so make a note of that. So at price 1, I did that in blue. So at P1, okay, we have supply is lower than demand, right? Supply is lower than demand. Right? Right, so the demand is higher, in other words, right? So that would, the price would be driven what? So price driven up towards equilibrium, right? It's always going to be driven in the direction of equilibrium, wherever it is, okay? So let's take a look at price 2. So at price 2, it goes up here, and over here, this is, we'll call this QD2 and QS, quantity supplied 2, right? And you would agree that they are equal, aren't they? Right there. So this price here is the natural state of, you know, the economy of that particular product. So supply equals demand, and we call that equilibrium. So price 2, right, supply equals demand, or quantities, right? This is our equilibrium price. Right? Let's take a look at price 3. Off to the right, it's a little bit higher, isn't it? Do this in green. So let's go up to the demand curve for price 3. right? Come over here. Make too much of a mess. So this would be quantity demanded 3, right? That's a 3. And if we keep going up, and then come over, right? This would be quantity supply 3. It's getting a little messy. I think you're following though, right? So here, how does supply compared to demand? Yeah, there's more. So what do you think would happen if there's a lot of things out there, right, and not much demand for it? And what would happen to the price? Okay, so here supply is higher than demand. Okay, so price is driven which way? Right, by the invisible hand. Price driven down. Okay, towards equilibrium again, right? And not everything is always sitting at equilibrium. It tries to stay there, but different things happen, right? Now this is all price, right? This is all price. If suddenly one of these other non-price determinants take place, right? You get taxes on this widget that go through the roof. Oh, Mercedes, right? That's going to shift the whole curve. It's not going to move along the curve, right? So when one of these curves shifts left or right, the equilibrium price shifts left and right. Does that make sense? Okay. You want to. So this is just a rough, most basic gist of macroeconomics. And when I say macroeconomics, it's like the broad 1,000-foot view of how an economy works, right? And then there's microeconomics, which they don't offer here at the school anymore. They don't have the school here. It's more, you can imagine it's like individual business stuff, right? Like how do they handle these things? And we're going to get into that too, with expense function, with cost to make things and whatnot. Okay? So we're going to kind of skip examples 1 and 2. Just take a quick look at it. Kind of odd to put them in there. We talk about wholesale prices. You're familiar with that, right? Like Walmart sells something for $10 on their shelf. They didn't pay $10 for it, right? They paid an intermediary, a wholesaler, maybe $3 or $5 for it, and sell it for $10, and there's a profit. They just stay in business and hire people, right? It all works out. And so there's markup, right? They might mark certain things up by a certain percentage. It's really simple, right? So it's basically just wholesale price plus markup equals retail price. And I feel kind of silly even going through any of this with you, okay? But I think you guys kind of understand that already. So let's skip to example 3. And 5, what, I can't, is it 63? 53. Okay. What color is it? All right. So let's click over to example 3 here. I'll do a new page, I think, probably. All right. Example 3. Did I hit? Sure did. Okay. So Carla, read that here, will you?
The graph shows the supply and demand curves for a widget with a price of $11. Explain what happens when the price is set at $9.
Okay, so that $11, what do we call that price? It's right there where the supply and demand curves intersect. Okay, so $11. 11, come on, is equilibrium. Okay, so what will happen if the price is down at $9? What happens? Well, why? So at $9, right, demand compared to supply is what? Right. No, it's a lower price. demand would tend to be higher, right? So demand exceeds supply, right? Or the other way around, you could say supply is less than demand, right? So we'll just say demand exceeds supply. Man, what is wrong with this thing today? My goodness, there's something wrong here. Demand exceeds supply. We have to just slow down. And so what price pressure is there? Upward or downward? Demand. People really want this thing and there's not much of it relatively. So there's an upward pressure on price, okay? Upward pressure on price. I mean, if that ever confuses you, just look at the graph, right? You see where 11 is on the graph, right? 9 would be to the left of that, and everything gets forced towards equilibrium, right? So maybe instead of trying to think of supply and demand, which there's more things left, just look at the graph, right? 9 is down below 11. It's going to tend to be pushed towards 11, right? Okay, upward pressure. You guys take a look at the check there. Read that over. See if you understand this. What's the check say? This graph say, okay, what happens if price is at $15? Remember, equilibrium is 11. Supply exceeds demand, right? And what's the price pressure? Yeah. Let me just take a look at that graph and see where 15 is compared to 11, right? Supply exceeds demand. And we have downward pressure. Pressure, okay? So remember, this is price only. No other determinants, supply and demand, come into play here, right? Just like any science experiment, you always eliminate all the other variables. We're moving along the curve. Anything other than price, do we move along the curve, or what does it actually do if it's a determinant other than price? It actually shifts the curves one way or the other, right? Natural disaster, that kind of thing, okay? Like if supply gets wiped out, it's going to shift the curve, okay? All right, take a look at example 4. And we might want our calculators for this. Dylan, read example 4, will you?
Company wants to base the price of its product and the name for the product, as well as the opposite. These will follow several of its current retailers to find out how many goods they will buy at different wholesale prices. The results are shown. The company wants to use linear regression to create the domain function. There's the equation of the domain function. The slope, line, or something.
Okay, so linear regression. Remember doing those in algebra, your calculator? So you have data, right? Been a while, but that's okay. It should come back to you, right? And hopefully, if we make a scatter plot of this data, it'll be, they want a linear regression, so hopefully that'll fit the scatter plot best, right? So let's go ahead and do that. Get your TIs there out of your desk. Okay? We're going to start entering this data. Well, I'm going to sit down here and it's easier for me on the keyboard. Okay? So we want to go into lists and spreadsheets, right? So we're going to open a new, and believe me, I kind of fumble around with this myself. So new, and then 4 is add list and spreadsheet, right? Okay. Now, the first thing I want to do is go up here, right? And our input variable is the price, right? So I'll just put a P up here. Okay? And then go over here, and what should we put there? Q, the quantity. I like these variables that make sense instead of X and Y, right? So let's go ahead and just start entering these guys in there. 5. Okay, so that's our quantity demanded, all those prices. Notice just looking at that, right? As these prices climb, what's happening to quantity demanded? It's going down, right? Has everybody had that in there? Do you remember how to do a scatter plot? So I think if we hit, let's see here, I want to do, got that, right? So I want to go into like data or something. Menu. So I hit the menu button, free for data. Here's probably good. I want quick graph. See number 9 there? And they get sideways. You guys know how to use the touchpad to move the cursor around, right? You want to kind of touch over here, click in here, so this vertical axis is going to be our which one? Price or quantity? No. Put price on the bottom, which by the way is backwards from traditional study of economics, but they keep it simple for you guys. And then you're down here, we're going to put price. I got something typed in wrong, don't I? What happened there? Somewhere, 5, 6, 5. Oh, 2, 5, 4, 6. 2, 5, 4, 6. There we go.
How do you do that again? Sorry.
Which part?
To get the graph up there.
I hit the menu button, right?
Okay.
And I clicked on data, and then quick graph. I'll slow down here for a second, make sure you got it.
Yeah, I don't know what I did. Did something.
So, if I'm in the graph, I hit the menu button. Either way. So now I'm going to hit the menu button, right? What was it? It was analyze. Let's see, number 4, analyze. Okay. And I want 6 for regression. I want to pick it. You can do a bunch of different, you can do quadratic regression, stuff like that. This looks really linear, nice straight line, right? So let's do 6 regression, and let's do show linear mx plus b. Right? And that's choice 1. And so there is the, you guys, I don't know if you know how to grab things. So what our equation then? Is everybody able to get that?
Yeah.
Okay. I'm sure there's a way to make that graph full screen so you can see the whole thing, right? All right, so we'll go with that so we can use that now, that linear regression. And so this is mathematical modeling of the real situation, right? I mean, businesses do this. They make mathematical models. So now they can make some predictions, right? They can plug in prices for X, right? Okay, well, they're using an X. Ours is P, right? Okay. So let's write down this particular equation, right? So we did a scatter plot first, right? So we just did our TI scatter plot. And a linear regression. Okay. So it kind of looked like this, right? Price, quantity, roughly, right? Just a rough sketch. And then we got our quantity demanded, our QD. I don't want to use a Y here. Quantity demanded equals, what was it, negative 1756. We'll just round it. Times price plus 30,239. Okay? So there's an equation that models the demand. They went out, they did some surveys and questionnaires and gathered data, right? The real-life situation, and they modeled that data. So now they have that equation, they can start using it, you know, to figure out exactly what kind of prices they need and how much they should supply, and so, right? That make sense? Okay? So this is MX plus B, right? MX plus B. Do you remember M is the slope of those equations, right? The rise over run. So we were taught that slope in a real life application actually means what? Rate of change, right? Rate of change, slope is rate of change in a real life situation, right? The rise over run. And the B, what was the B? Well, the y-intercept, right? So we're across the y-intercept, but in a real life situation, what does that mean? Remember, the slope is the rate of change, and the y, where it starts at the y-intercept. Well, that's up here, right? This is our like 30,000 or whatever, at a price of what? 0. So they'd be willing to accept 30,000 of these things at $0. Wouldn't that be known as the starting point? So your MX plus B. M is the rate of change, right? And B is the starting point. What is our slope, though, in real units, right? So our M, right here. You notice that the M, this rate of change, is negative as you put prices in, right? Let's get the units in there. What does this mean? It means negative 1,756 units per what? Every what? Prices in what kind of units, guys? Dollars for every $1. Right, of increase. So as the price goes up $1, the quantity demanded does what? Goes down 700. So $1 higher, there'll be this many fewer demanded at that $1 higher price. Does that make sense? And every dollar you add to it, it's that many fewer demanded, right? So for every dollar, let's just say for every $1 increase, right? We have a decrease of 756 demanded. We have 1756 fewer units demanded. Right? So we're not using our linear equation MX plus B now just for, you know, what's and giggles, okay? We're going to analyze what slope means, rate of change, right? What that B is, it's a starting point. Would a linear regression make sense? You don't have to write this down. I'm just real quick. Would a linear regression model make sense if the graph looked like that? Or like this? Oh, if you had a graph, if your data scatter plot looked like this, it looks more like quadratic with an x squared, right? This looks like exponential, remember? Okay? So in this case, linear seemed great because that's a nice straight line, right? Okay? But if you try to fit a linear equation to something that does this, how accurate do you think it would be? When you use it as a predictive model, right? You're going to be off quite a bit, so you might want to try different regression. Your calculator goes off, right? Okay? Sometimes you get your scatter plot, you could try 2 or 3 different types of regressions and see which one of them fits it better, right? You can graph it and see which one of them goes through most of the data points, and that's my most accurate model. Okay? All right, so anybody have any questions on this supply and demand, this macroeconomics thing, right? Equilibrium price pressures, Adam Smith's The Invisible Hand, okay? You guys weren't here. What does ceteris paribus mean, Carly?
All equal.
All else being equal, meaning what? It's the only thing we consider as far as quantity, demand, and supply. Price is the only determinant that we look at as we move along the curve, okay? What does any other determinant do to the graph? Shifts the graph, right? Doesn't move along the graph anymore. Anything other than price actually moves one or the other of both graphs themselves. Price moves along the graph, right? Ceteris paribus, price determinant of demand, okay? All right.